there is the circuit emulation mode, which is a electronic load mode that allows you to create multiple permutations of RLC networks and simulate those on the load. So it gives you the ability to create a multitude of linear and some nonlinear application loads for test purposes. So here's a summary of some of the circuit topologies that are supported by this circuit emulation mode. You see a lot of these are just linear combinations of R, L, and C's. Multiple combinations in series and parallel permutations are available that you can select from. The individual values of these R's and L's are accurately programmable, so you can program the values and also under program control time vary those values with a particular pattern or rate. A couple of the ones on the bottom right are nonlinear circuits as well. So you see that they are rectifier circuits with additional RLC filter networks, and the output very useful for simulating, power supply inputs, different type topologies that you can simulate with the electronic load instead of waiting for some hardware prototypes to start evaluating the circuit design. So that can certainly speed up some R&D pre-testing for your power supply developments. Applications for loads are very wide, clearly very similar to where you find AC sources or grid simulators being used. In this case, it's for the load side. So there are applications in aerospace and defense, and we can support both 400 hertz and 800 hertz frequencies on our loads. So there covers both commercial as well as military and defense applications. Examples, for example, are loading EV inverters, battery storage system, charging, discharging of battery systems in DC mode. Bidirectional EV chargers, obviously it can be loaded up with electronic load for load testing. Solar inverters, we already mentioned the use of the RLC mode in anti-islanding test setups and other solar inverter test setups. Grid compliance testing, if you want to test your grid sources for stability under various load conditions, it's easy to simulate those on the electronic load. So a lot of applications for AC and or DC loads that are available on the AZX and ELC products. Again, single phase, three phase, or split phase, or combination of load and source on different outputs for single phase applications as well. So again, there's a multitude of application industries where loads can be used, especially in aerospace and defense at higher frequency buses. You can create load conditions and load scenarios to test your power distribution buses and your power sources on the airplanes or on the equipment. EV inverter testing, especially bidirectional chargers and EV motor drives that can generate power in both directions, can be tested. Battery storage system, mostly DC applications, of course, and our units are both AC and DC capable. Battery bidirectional V2G and V2X systems to test for grid immunity against grid anomalies to make sure they operate under adverse grid conditions within spec. And solar inverter testing, same type of impedance testing as possible with the electronic loads, as well as grid compliance testing. So the wide variety of applications in different industries where both grid simulators and electronic loads can be combined to create powerful programmable test setups. Circuit emulation is not very common on electronic loads. Most electronic loads will offer things like constant current, constant power settings where you basically control the voltage and the current, the power. CE is more advanced, so it basically simulates dynamic behavior. So it requires accurately timing in terms of adjusting the values of the RLC components or multiple RNC components in the network, simulating the behavior of the network topology that you're selected. It needs to be accurately modeled, and also has to stay stable under transient conditions. it requires typically to do any power factor from +1 to -1 through 0. It needs 4-quadrant capability in order to do that. Low noise and ripple can be beneficial as well. And to do the real-time calculations to meet these load requirement simulations, you need very fast processing. So typically either gate array or DSP type, real-time processing of settings and feedback from voltage and current readbacks. So very challenging capabilities that are requiring very high-end controllers that are built into these units. Again, summarizing, there's 15 standard topologies that you can choose. So the parameters are all programmable. Simulations are supported up to 10 kilohertz frequencies. So you have a very wide range of operation, keeping everything stable and preventing any resonance conditions. Voltage and current feedback, high-speed readback is available as part of these systems, and synchronization is done in real time as well, with the ability to have a wide range of impedance from high to low. So a lot of power, a lot of capabilities built into these electronic load solutions. I mentioned the 10 kilohertz bandwidth. Obviously, the voltage is derated above 1,000 hertz. So from 1,000 to 10 kilohertz, there's some voltage deranging because of the high frequency that is supported, up to 1,000 hertz. From 15 hertz to 1,000 hertz, you have pretty much full scale 480 volts or 240 volt single phase line to neutral capability. So you have a pretty wide dynamic operating range on both the grid simulators as well as the electronic loads. Oops. So this allows you to accurately monitor, this being a simple parallel example of an RLC load. So basically the source is variable, and then the components are variable, so you can control the power factor and the overall impedance while you are sampling the voltage and current, 3 voltage and 3 current channels with a high sampling rate digital scope that is built into the load and built into the grid simulator. And the advantage of the internal scope is that it's very easy to trigger on power source or load events. As you're changing a load event or you're changing a setting on your grid simulator, you can tell it to the scope, internal scope, to trigger at that event and then capture the events for you. So it's very easy to position your data acquisition of your scope at the right moment as you're controlling the actual scope and load as well. The AZX series is a power system that is available in a single cabinet starting at 30 kilowatts up to 55 kilowatts of power. It can be paralleled up to 10 units to 550 kilowatts. It's a 3-phase system for higher power applications. They can be configured up to 1.1 megawatts for very large DERs. It's a full 4-quadrant regenerative power with a 90% efficiency, so most of the power will be able to be returned to the grid, especially convenient for load applications where you are absorbing a lot of power, so you're not wasting it by burning it off, but you're actually returning most of it back to the mains. So that will save quite a bit of energy over time. Wide operating environment for voltage and frequency, so you can program up to 480 volts line to neutral or 830 volts line to line, so you can handle 600 volt grids as well as 480 volts and 400. And for DC applications, it has three outputs up to 680 volts DC each. So it allows you to do both AC and or DC type testing. Overcurrent capability for short periods of time to ride through inrush currents, and the ability to not only run single, split, and 3-phase, but also combine multiple channels. So if you had a single phase DER, you could use one channel for a grid simulator and a second channel for the electronic RLC load. So you could do a test setup with a single unit. So very flexible in that sense. Load is an option on the grid simulators, or you can also add a dedicated electronic load version, the ELZ model, which acts as an electronic load only to create your test setups, and all these models are controlled from a web browser interface called Smart Source Suite, which doesn't require you to write any software or use any instrument drivers or any other resources to be able to access and program and control these units remotely.